Hello, and welcome to TI's Demystifying Surge Protection video series. This is the first video in a series explaining the fundamentals of power surge protection. Over the course of 5 videos, we will give a brief introduction to power surges and what causes them, the IEC 61000-4-5 regulation standardizing surge testing, an overview of surge diode specifications, go over some common mistakes that designers make while designing a surge protection stage, and then discuss TI's flat clamp surge diodes. First things first, what is a surge? A surge is an unexpected and transient voltage or current spike that is caused by nearby electronics or the environment. Surges are important to understand because they can cause electrical overstress damage to IC inputs, creating system failures. A critical part of system design is being able to prevent these failures by safely shunting the transient spikes to ground and ensuring that they don't cause any damage. Compared to ESD pulses, surges are much longer in length and contain far more energy, making them critical to protect against. Unfortunately, surges are complicated and have many different causes. Generally speaking, assessing the environment that a system will be operating in makes it possible to identify systems at high risk of seeing large surges. If a system operates outdoors nearby to potential lightning strikes, contains high voltage, current, or power inputs from inductive or capacitive loads, or has regular hot plug events, it's likely that a system will be exposed to surge events and needs to include dedicated surge protection. There are many other events that can cause surges, but these tend to be the most common causes. Even if a system is low-powered and has limited ability to internally produce a surge, it can easily see surges coupled inductively from nearby equipment. For example, this means that in a factory setting, even a low voltage and current 420 milliamp loop can see major transient voltage or current spikes if a nearby motor abruptly stops and produces a large transient spike. This transient spike can inductively couple from the motor cable into the 420 milliamp cabling, creating a reduced but still dangerous spike on the loop. Induced surges are more common for equipment with long cabling that will run in parallel with other cables, or proximity to high-powered equipment that will originate surges. While designing any electrical system, evaluate based on these risk factors to decide if the system is at risk of seeing surge events. If there is a risk, take the time to dig deeper and design an effective protection method. In the next video, we will look at how to characterize these surges by discussing the IEC 61000-4-5 standard, which designs test methods for ensuring surge robustness. Thank you for watching.